handouts, and have you gone over the handouts or the recordings that have been posted? Not yet? All right. I think I'll just do a tutoring session. I don't think we need to record since I'm not going to do an actual class. I'll first do an announcement to the class. Class 1 hour. Questions. I don't think I can annotate. Okay. Let's go here. Arif, do you already know about the competitions, what they are? Probably open chat. Oh, there we go. No? Okay. So I'll start from the very beginning. I can go up to 5:40, so we'll have half an hour to move through what we've done so far as quick as possible. As for you, Maxwell, I mean, it's good review to stay along. I don't want to move to a topic that you've already known because that would leave Arif behind. So it's your choice what you want to do, Maxwell. I guess you can leave since I'm not going to be teaching anything you don't know yet, or you can hang around, whatever is up to you. All right, so Math Counts Arif is going to be a nationwide middle school math competition. So you should contact your math team. They should have already started. No, it's like depending on where you live, math team may or may not have already started. So, and your school may or may not even have a math team. I don't know. I would just check with your school. So you're gonna spend pretty much fall preparing for Math Counts and AMC 8. Math Counts starts off in January with a school round. So that's going to be within your school, you're competing against other people in your school to see which people at your school will be going to chapter. So chapter is going to be in the next round. It's going to be basically locals, whatever schools are inside of your county. If you do well in chapter, you get to move on to state, which is every school in your entire state. And then the top 4 individuals in state get to go to nationals, which is in Orlando or DC every year in around May. And you get to compete and represent your state. All right. Each competition, so each round, school, chapter, state, and national, has 4 different rounds. So there's sprint round, target round, team round, and countdown round. So sprint, target, and team actually count. Sprint is going to be 30 problems, and you have 40 minutes to solve those 30 problems. Those 30 problems are going to be a short answer, which means you have to give a number as your answer. Same thing with target, except they're going to give you 2 problems, and then another 2 problems, and then another 2 problems, and then a final 2 problems for a total of 8. And for every 2 problems, you get 6 minutes. So these problems are going to be a bit tougher, but you can use your calculator on this round. Also, it's worth more points. That's why it's called target. If you get target questions right, you get more points than in sprint. In team round, team round's going to test your collaborative skills. You're going to be given 20 minutes to solve 10 problems, except you're also with 3 other people and you're allowed to use your calculators. And then in countdown round, that's just for fun. It's after all the other 3 rounds are done. It's sort of something to unwind. If you did well, if you did well individually, you can participate in like sort of a buzzer race. Like some adult's going to read a problem on the slides, and the first person to like slap their hand or hit a buzzer and that says the correct answer is going to win. Okay, each school can only send 10 students, including 1 team of 4. Yep. So the team rounds for the team of 4. The top 4, I think I've already talked about it. Any questions about Math Counts, Sarib? Where is chat? I don't see. Oh, here it is. Nope. Cool. All right, AMC is completely different. It's going to be one big nationals competition that everyone can do. There's no special in between rounds. You just do it. It's going to be online this year in November. There's 25 multiple choice questions and it's 40 minutes long. It's also for middle school students, designed to introduce students to problem solving. Let's see, you should also contact your math team to register for that. Let's see. It's pretty straightforward, just 25 multiple choice questions, A, B, C, D, E in 40 minutes. You can, for AMC 8, because there's just one competition, you can get a couple of awards. If you score in the top 5% of participants in the world, in the nation, you get the honor roll. Top 1% scores you just the distinguished honor roll. You can also, if you do well on the AMC 8, you're going to receive an invitation to do the AMC 10 and 12, but you can do that without the invitation either. The 10 and 12 is going to be high school level competitions that are harder, but they are what you use to qualify for the AMI, the USIMO, the United States Math Olympiad, but I don't think you'll be doing that in middle school. All right, will be covered in this course. Basically, I'll be covering all the basic topics in problem solving, like algebra, geometry, accounting and probability, number theory. After that, some practice. I'll give practice problems every week, and in the slides, different key concepts for problem solving strategies and how to find resources, maybe some math contests. Because of COVID, I can't really find any for you guys to compete in yet, just AMC 8 for now. And then the problems are going to be taken from previous AMCs. All right, arithmetic. Since you're in 8th grade, what class are you in right now? Meaning, I mean like algebra, geometry. Actually, I should probably know, like, do you live in the DC metro region? That's where I'm stationed, but to my understanding, it's around the county. Algebra 1, that's where you're taking right now? Yep, okay. So I'm gonna assume that means you already know order of operations, addition, subtraction, multiplication, division. What about variables? This is so long ago, I don't know if I learned about variables before algebra. Let's see. I think there's an easy way to remedy this. Do you know how to do single step like linear equations? Yes, okay. How about systems of equations? That's where you have 2 variables and 2 equations. Yes. I'm not asking you, Maxwell. I already taught you. Systems of equations. So that's where they give you, okay, I think, so that should have been where algebra 1 starts off. So let's do a quick review. A system of equation is going to be when you have some amount of variables and you want to find all of those variables. Solve for all of those variables. For n variables, we need at least n equations to solve the system of equations. So n in itself is going to be a variable. If we have 2 variables that we want to solve, we need at least 2 equations to be given to us in order to solve it. If we just get 1 equation, we can't solve it. It's going to be infinite solutions. I don't think I need to talk to you about this yet since we're about to go over it. Okay, there's 2 main ways. There's 2 main ways to solve a system of equations. I should really present a system of equations. So the first way is a limit note substitution. Okay, so I've given you a system of equations here, x minus 12y equals 2 and 3x plus 6y equals 6. So we can rewrite the first equation as x equals 2 plus 12y. So what we do here, we add 12y to both sides, and we have just x on one side. We call this isolating the variable. We're going to get only one variable on one side of the equation. Now we found some expression that represents what that variable x is. In this case, x is equal to 2 plus 12y. So we can plug that into the second equation. So in this case, we're going to set x as equal to 2 plus 12y plus 6y equals 6. All right, and then this just becomes a linear equation. All right, let's go down here where I actually wrote it out. I'm going to combine like terms. 3 times 2 is going to be 6. And then, so that's just going to be 1, 6. And then 3 times 12y is 36y. I'm going to add 6y to get 42y. If I subtract 6 from both sides, I get 42y is equal to 0. So y has to be equal to 0. And then we have to solve back for x. So we're going to plug y back into the first equation or the second equation to get x is equal to 2. Do you understand that? Is there anything I missed? Anything you don't understand on this page? You understand? Cool. Elimination. All right, here's another way to solve system of equations. So I've given you the same system of equations, but in this case, we're going to multiply the second equation by 2 on both sides. So we're going to get 6x plus 12y is equal to 12. All right, now we're going to do something crazy. We're going to add equation 1 and equation 2. We can add equations, by the way. That makes sense, right? If these two things are equal to each other and these two things are equal to each other, it's going to be something like a equals a and b equals b. We can add those two equations together to get a plus b equals a plus b, which is a true statement. So that's why we can add, subtract equations, multiply, we can basically do operations with equations. Chat. Oh, okay. I see I've lost you. What do you not understand about this, like the adding equations part? Yes, that, okay, cool. How about this? I give you a equals b plus c. All right. I also have d equals e plus f. All right, because d and e plus f are equal to each other, I can basically interchange them whenever. They're the same thing, they represent the same thing. Same thing goes with a and b plus c. A is equal to b plus c, b plus c is equal to a. So since these two things are the same thing and these two things are the same thing, if we were to add these two equations together, that means just look on the left side, add a plus d. Then, hang on, sorry, I should phrase this better. Let's just add everything on the left, only everything on the left. So I'm going to have a plus d. But we can substitute a and d for b plus c and e plus f. So therefore, a plus d is equal to b plus c plus e plus f. Yep, you got it. Okay, same thing. We can do the same thing with subtraction, multiplication, division, whatever, because equations just represent the same thing. All right, so going back to our original thing, if we add the things on both sides, so we get, the reason why we multiplied the second equation by 2 in the first place is because now that these 12y's, the positive 12y and the negative 12y cancel out. All we're going to have is 7x and 14. So x is going to be equal to 2. And then we plug back in 2 to get 2 minus 12y equals 2. And then y has to be equal to 0. So we got the same solution, the same answer. All right. Sample problems. Ariba, I just want you to try number 1. Maxwell, if you're still there, you can do number 2. I don't think we did that in class. But yeah, we put it in the homework. It's a good review. Your choice, Maxwell. I need to get some water. All right, Arib, I'm gonna start solving this with you. So which method did you pick? Sorry to interrupt your solving, but if you could type quickly in the chat which method you used to solve the equations. Method 2, that's gonna be elimination, okay. I'm gonna assume that you multiplied the second equation by 4, since you used the elimination, yep, okay. So let's simplify that. We're gonna get 16x plus 4y is equal to negative 72. All right, notice that if we were to add both equations right now, we'd cancel out the y's because there's a negative 4y in the first equation and a positive 4y in the second equation. So if we add, we're gonna get 25x is equal to negative 150. Let's divide by 25 on both sides and we get x is equal to negative 6. Cool. But we still need to solve for y. So what I'm going to do is plug x equals negative 6 back into this equation. So we get negative 24 plus y equals negative 18. If we add 24 to both sides, that's terrible. There we go. That still looks bad. We're going to get y is equal to 6. So we get negative 6 and 6. All right, cool. Looking good. All right, so in the second case, I put it on the homework for class 1. So if you look at week 1 homework, you'll be able to see this. If you want to submit anything, let's see, x plus 2y, I want to see. In this case, you'd want to do substitution elimination, except with 3 variables. So just to start you off, I think if you add the first two equations, you'll get 3x plus 3y equals 2, which is pretty interesting. You can also notice that the third equation can be simplified if you divide everything by 3. That's not what I meant. Hang on, let's do this really quickly, actually. If we add these 2 equations, we get 3x plus 3y equals 2. And then we can plug this back in here to get 2 is equal to, 2 plus 3y plus 3z equals 6. So we get 3y plus 3z equals 4. That was a bad idea. I thought it was 3x plus 3z. Hang on, let me clear this. No, I shouldn't. I think I did this right away. 3x, 3y, and then 3y plus 3z equals... No. Yes. That's right. What am I doing? Okay. We have 3x plus 3y equals 2 and 3y plus 3z equals 4. It looks like we should find something with x and z. Well, let's divide by 3 on both sides here. We get x plus 2y plus z is equal to 2. Where'd you get the 2 from? What do you mean, what 2? Actually, let me clear everything because I want to start over. Okay. I got the 2 by adding these first 2 equations to get 3x plus 3y equals 2. And then I noted that 3x plus 3y can be simplified. That's probably not the best path to take. No, I'll do something else. In this case, you can divide by 3 on both sides to get x plus 2y plus z equals 2. Sweet. Flipping physics has entered the room. Interesting. All right, I'll have to do something quickly with you three. Once I finish solve this, head's not in the game today. X plus c, 2y. I can set these two equal to each other and then make it. Okay. No, from the 2 plus 3y plus 3z. Oh, okay. I already cleared everything. So what I did was I noticed that this is equal to 3x plus 3y plus 3y plus z plus 3z is equal to 6. And then since we already know that 3x plus 3y is equal to 2, we can just simplify that to 2 plus 3y plus 3z equals 6. All right, running out of time here, and I want to do something with all three of you. Oh, or all two of you, because flipping physics left. Okay. Never mind. Okay. Let's see. Sorry I have to stop in the middle of solving that, Harib. This is in the first handouts that I sent out the first week. If you're, feel free to go through all the slides and the recordings. I don't think there's a recording for the first class, but there should be for the other classes. If you want to follow along with what our class did that day. There's also the slides if you want to follow along by yourself. And then there's, of course, the homework. If you turn in the homework, I'll get back to you and work with you on any problems that you've missed. All right, let me stop sharing and get ready. Aha. All right, hopefully you're back, Maxwell, because I'm about to do stuff with both of you. This is the art of problem solving. This is the website that I talked about the first day of class, the first class period. So this is probably going to be your best resource for problem solving. They have all the previous AMC 8 problems. You just have to search for it. AMC 8 problems. And then we have all the ones from 1985 to last year, along with solutions for every problem. But more importantly, they have online classes, but I think the best resource they have is something I need to find. What? I probably shouldn't have left AOPS online. Okay, resources, cool. They have something that's really interesting called Math Counts Trainer. I recommend that you get an account immediately on this. Ignore my username. I made it when I was in like 6th grade. All right. Let's check settings. So they have a bunch of different problems based on which level you want to play. For example, I'm going to start off with school right now. So we have Jessica hikes east for 9 miles, then turns and hikes south for 12 miles. So I want both of you to solve this problem. And if you guys are doing well with school, we'll move up to chapter and then state. And I haven't unlocked nationals because I wasn't a good student in middle school. Hikes east for 9 miles, then turns and hikes south for. Aha. Okay. All right, Maxwell got 15. How about you, Arib? Not sure if you guys did like simple geometry before Algebra 1. Still solving? Okay. So we want to find what this length is, basically, this dotted line. Not sure who Flipping Physics is, but if you could change your name to your real one and then participate with us, that'd be great. Okay, and so is line. Okay. Wow, 5:34, and now we have enough people to have an actual class. No matter, we shall participate with Elaine and physics. All right, so this problem is just what we learned last week with right triangles. So there's something called the Pythagorean theorem, where if you look at the legs of a right triangle, the sum of the squares of the legs should be equal to the square of the hypotenuse. So that means 9 squared plus 12 squared is equal to whatever the hypotenuse, let's call it x squared, is. So in this case, 81 plus 144 is going to be equal to x squared. So 225 equals x squared. And then the square root of that's going to be 15. Cool. Clear annotations. Cool. Let's change to something harder. Let's go to chapter round. So this should be a step up in difficulty. All right, here's an algebra one, which is good. No, it's not. It's not algebra. Oof. Yeah, I'm not at 46 on chapter because I stopped doing math counts trainer after 8th grade. No matter. We'll get to 46 with you guys. Perfect. All right, a positive integer x is 2 more than a multiple of 3. This is number theory, which I haven't taught you guys yet, but we can try it. A positive integer x is 2 more than a multiple of 3. Its units digit is the same as the units digit of a number that is 4 more than a multiple of 5. What is the smallest possible value of x? Whoa. That's pretty cool. All right, its units digit. I think the key place to start is here. Its units digit is the same as the units digit of a number that is 4 more than a multiple of 5. So note that, let's count off the multiples of 5. We have 0, 5, 10, 15, 20, 25, blah, blah, blah. You'll notice that the units digit is always going to be 0 or 5. So if we add 4 more to those, we're just going to get something with 4 or 9 in the units digit. So what that means is that x has to have 4 or 9 in its units digit. So we have to pick 4 or 9. Interesting. All right, this one's pretty simple. So in this case, we're asking for what the smallest possible value of x is. And since we know it's a positive integer, let's start from the very bottom with 4. Okay, 4 is not 2 more than a multiple of 3. 9 is also not 2 more than a multiple of 3. But 14, which is the next number in our sequence, is going to be 2 more than a multiple of 3. 14 is 2 more than 12, and 12 is a multiple of 3. So that's how you would solve that. All right, I went through that one quickly because I'm going to teach you later. Here is something you guys should know. What is the largest possible area in square centimeters of a right triangle with one side of length 12 and one side of length 20? All right. How should I do this? Should I have 12, 20 here, and I don't know, something here? Or should I have 12 and 20 be the legs? Also, 12 can't be the hypotenuse because 20 is bigger than 12. All right, yeah, the latter option. So in order to maximize the amount of area we can have of this triangle, we're going to put the 2 values that we already have as the legs so that we can have an even bigger value for the hypotenuse, and that's going to create more area. But we don't need to find the hypotenuse. All we have to do is base times height divided by 2. So that's going to be 12 times 20 divided by 2. 12 times 10 is just going to be 120. All right. Everyone get how I solved that? It's 540. Oof. All right. Get any questions? I'm assuming it's fine. All right, that's fine. It's 5:40, so if you have to leave, you're totally free to. I'm gonna keep on doing this for the next 10 minutes. Oh, Elena left us, sorry. In the diagram, the area of triangle ABC is 27 square units. Huh. What is the area of triangle BCD? All right, I'm not gonna do this. I'm gonna leave this just for you guys to do. When you give me your answer, you have to prove to me how you did it. So explain to me how you got that answer. $117. All right. So what I just wrote out, so blue represents the area of ABC and red's going to represent the area of BCD. So in this case, we're going to use algebra to solve a geometry problem. So we know that the formula for the area of a triangle, the formula for the area of a triangle is base times height divided by 2. So in this case, the base is going to be 26 plus 6 for ABD. Oh, I read the problem wrong. Oof. Don't do that. Don't be like me and skim through it. Okay, it's ABC. ABC is the tiny one, is the tiny triangle. Let's do that. ABC and then BC. Okay, cool. So blue is going to be this one and red's going to be this one. All right, blue. Now I have to rewrite this. 27 is equal to 6 times the height divided by 2. And then the area of BCD is going to be equal to 26 times the height divided by 2. And you guys know that because that's just base times height. We know the bases of the triangles and they have a common height, which is h. So they already gave us 27 is equal to 6h divided by 2. So 3h equals 27. So Max Ariba is correct when h is equal to 9. Then we just plug 9 back in. 9 times 13 is going to be 117. So yes, 117 is going to be correct. Both of you solved that correctly, but I made the same mistake in Maxwell by assuming that it said like the area of triangle ABD is 27. So, oof, but the good thing I caught it. All right. Yeah, I'm pretty sure this would be something that most of us would get wrong. 117. All right, let's do one more problem. Why hasn't my rating gone up yet? It's still at 41. Angry. Okay, I want to skip that. Can't skip that until I solve it. No, let's do a state route. Oh, yeah, we can do this. $114 from Maxwell. Interesting. Maxwell, could you care to explain how you got that answer? I think it's correct. I know it's correct. All right, Arif doesn't know how to do this.
There's something called the Pythagorean theorem.
So Arif, hang on. So Arif, this is what we used on the very first problem we just did. So if you have a right triangle, that is a terrible right triangle. I'm going to redo that because I'm very sorry for my mistakes. Boom, boom, boom. All right. If you have a right triangle, we call this side the hypotenuse. And then the hypotenuse means that it's the longest side of a right triangle, and that means that it has to be opposite this right angle. So this is the hypotenuse. And then we call the other two sides legs, or just A and B. That the H stands for hypotenuse, I guess. So in any right triangle, A squared plus B squared is equal to H squared. This is something that I went over in last class slides, if you want to check that out later, Arib. Yes, you know the theorem? Okay, so the same thing is going to apply here. 12 and 15, if you were to plug that in, you would get A squared plus 144 is equal to 225. And then you'd solve that and you get AD is going to be 9. You can also notice that there's a Pythagorean triple here, 3, 4, 5, except you just scaled up by 3. In this case, there's 15 and 17. Do Pythagorean theorem again and get that this is equal to 8. Now, all you have to do to find the area is find the sum of these two, the areas of these two triangles. So 9 times 12 divided by 2 is going to be 9 times 6, or 54. And then in the second triangle, 8 times 15 divided by 2 is equal to 4 times 15, which is going to be equal to 60. So 54 plus 60 is going to be 114. All right. Do you see how we got that, Sharib? Yes? All right. 114. What is this doing in state? Huh. All right. That's all I have for you guys today. I would recommend getting this math counts trainer, logging in, getting started, doing like at least, I don't know, 30 minutes a day. That'll do way more good for you than attending this class, attending any class. Practicing by yourself, I say, is probably the best way to increase your problem solving skills. Maxwell. All right, stop sharing. Do you guys have any questions? I don't know why we're recording.